Hi, and welcome to the spoken tutorial for VisualFirebird programming interface for Fireboard 5 with the Atmega 2560 processor. Now, I'm assuming that you have the folder name VisualFirebird, which is a NetBeans project, in place, and I'll just run you through how to open it as a project in NetBeans and how to execute it. Once you open NetBeans, you go to click on File and Open Project. You'll see that in the location where you have downloaded the folder VisualFirebird, it is marked with a different logo indicating that it's an NetBeans project. Select it and click on Open Project. You can see the various files within the project by clicking on the plus signs. So you see that there is this file called workspace controller.java, which is the main file. Now once we have opened this project in NetBeans, we can first clean and build project by clicking on this button, and then we run the code. The build and run operations might take a while, but once the run is completed, you will see a window open which looks like this. This is where we'll do the programming using the blocks. You can see on the left side that there are different categories marked as run, actuators, logic, sensors. So each of them has different kinds of blocks. We can drag a block and place them in correct positions and see how the blocks interlock. We also notice that different blocks have different shapes. This is to ensure syntactic correctness in the program we will be generating ultimately. So now I'll build a simple program. The outer block here is the forever block, which basically says that whatever code you add inside it should happen inside an infinite while loop. So I'm basically going to test for some condition inside this forever loop and take some action. I'm writing is checking if the value of the white line right sensor is equal to the value of the white line left sensor, and if it is so, go forward with the speed of 300. Now once I've written such a program, I can save it as an XML file for opening it later and if I want to modify it later. And I can open it using the open button, but note that you have to save it in an area which has the files langdef.xml and langdef.ttd also along the same folder. Otherwise the XML, the program we saved, won't open correctly. Now if you want to generate the C code, we click on the button get C code. We save it in the appropriate name with the extension .c. And you can see that by opening the file in which you have saved it, you can see the C code inside that file. Alternatively, what you can do is you can go back to the NetBeans interface, and in the output terminal of NetBeans we see that the C code has been generated. Is to take the C code and open AVR Studio 4. There again you open a new project and create a C file with the name of your choice and paste the C code onto that file. Here under header files we would like to add the firebird.h file, which you will find inside the support folder, the NetBeans VisualFirebird, within the VisualFirebird folder. And also we want to set the device to Atmega 2560, and in the include directories we would like to include the folder which contains the firebird.h file. So once you do that, we are all set, and you can see the firebird.h file. It contains all the interface API functions for the Firebird 5 bot, which is such as switching on the buzzer, switching it off, moving motors forward and backward, and so on. Once you have done all this, you can press F7 or click on this button which says build active configuration. You see that the build has succeeded. You will see some warnings, but you can ignore them for the time being. And along with the build, see that wherever you have created your project C file, in the same folder you will see another folder which has been created by the name of default. Within that folder you will see many files with different extensions. Among that, test file name .hex is the hex file will be burning onto the bot to execute the code of the bot. Now that we have seen how to make programs and build them using AVR and burn them onto the bot, let's come back to the visual programming interface and look at some of its features. So if you look at the left hand side, you will see that among the different categories there is one category called actuators, which has functions blocks for indicating motor movement of bot going forward, backward, or turning left, turning right. Also for the buzzer, and if you want to display some text or a number on the LCD screen of the Firebird, you can use the LCD block. The empty block is basically does nothing. It is there for functional completeness, and the stop block does as what it is expected. It stops the motors. This block is the variable declaration block, using which you can declare different kinds of variables. And inside logic, you'll see that there are again number of blocks. First three are saying are control flow blocks, which are if-else statements or repeat statement. And then after that you see that the block shape and color changes. These are basically Boolean function blocks, which are so the first one is for example is an AND of two function, which is a left argument and a right argument. And later on we see that these blocks are measuring equality for different kinds of variables. The first one is checking equality for strings, the second one equality for numbers, and the third one the first one is checking equality for two given quantities, and the third one is checking whether two strings are equal. The fourth one is checking if two characters are equal. And at the end we have the Boolean value blocks, true and false, with no arguments. Now once you have put a block on the interface, you see that we can change the block to another one in the same family by pressing on the down arrow and choosing a different function. After logic, we move to the sensors. These functionality right now is for 5 sensors, which are the right line sensors, the front IR sensor, and the ultrasonic range sensor. All of them have the shape which is same as the shape of block number. The number block is blocked with an editable label, meaning you can change the value being shown on the block, get different numbers. So after sensors, we can define procedures, we can define variables. The first one is for integer variables, the second one is string variable, and the third one is for character variables. And we can also have actual text. The first one denotes a string, and the second one is for capturing a character. And then there are all the plethora of mathematical functions like plus, multiply, divide, random, tan, minimum, maximum, remainder, and so on. And finally we have the ZigBee protocol blocks. So to show how the ZigBee blocks are to be used, we'll open a program which you have written previously and explain it. So this is the program which uses the ZigBee communication module. I'll explain what it is doing. So inside the forever block, we are just displaying the value of the front IR sensor on the LCD screen, and the ZigBee interrupt code is as following. If the received data character is A, we move forward with a certain speed. If it is S, we move backward with a certain speed. If it is Q, we stop. Now, the simple code can be burnt onto the bottom. You can see a demo of how it works. So thank you for watching this tutorial, and we hope you enjoy working with VisualFirebird programming interface.